Hey guys, today we're going to do Unit 9, Lesson 1, and I've only got 2 lessons in this unit, okay, but it is statistics. So today's lesson is on permutations and combinations. So let's talk about quite a bit of stuff today. So the fundamental counting principle says that if a decision M can be made in M ways, and decision N can be made in N number of ways, then the 2 decisions can be made in this number of ways by just multiplying them together. Okay? So let's look at an example. The ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you only choose 1 flavor and 1 topping? So you're getting a cone, you're getting 1 flavor, and you're getting 1 topping. So there are 3 different choices to make. This choice offers 3 different options, 15 different options, and 8 different options. If I just multiply all of those together, that represents the total number of options that I have available. Okay, so let me just use my calculator real quick. 3 times 15 times 8, and I get 360. There's 360 different options. All right, so that's the fundamental counting theory. Now, for number 2, let me zoom in a little bit. I've added a few notes. Sometimes they expect you to already know some things. So Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? So in this case, we can't just do 3 times 4 and get 12. 12 license plates for an entire state would never, ever be enough. So what we really need to take into account is that, well, of those 3 letters, there's 26 options because there's 26 letters in the alphabet. So 26, and then there's going to be 3 of them. So I just raised it to the 3rd power. You also could have done 26 times 26 times 26. It means the same thing. And now my 4 digits. Well, the only single digits that are available are 0 through 9. So that's 10 numbers available. And they can be put in any different order. It doesn't matter. Okay, so 10 possible numbers, and we're going to get 4 of them. And they're allowed to repeat too. So let me type this in, and now let's see how many are available. 26 to the 3rd power. Okay, times 10 to the 4th. Holy moly's. Okay, here is my number. 17576 with 4 zeros. 1, 2, 3. There we go. That is our answer. That's a whole lot more than 12. All right, let's talk about what is a factorial. A factorial. Factorials are extra happy numbers. Like they have this exclamation mark because, that's how I always thought about it anyway. The factorial is any number, okay, and it's going to look like this. And so it's just going to be the product of all the numbers starting at n and going down to 1. So let's look at example 5. So 5 factorial is this. 5 times 4 times 3 times 2 times 1. And then you would just multiply that out, okay? But I do want to show you how you can do this both in your graphing calculator if you have the TI-84 app on your phone. I'm also going to show you how to do it on Desmos, okay? So So to find the factorial option, I need to click the math button. And I don't know if you can see this. The math button is right under the alpha button. Okay. So, oh, and I clicked the alpha button. Try again. Okay, here's math. I'm going to scroll all the way over to where it says probability or prob. Okay. And now what I see is this factorial. Okay, which is option number 4. I don't know if you can see it really, really well. Okay, but that is a factorial. So if I'm going to type, I got to type the number first, 5, math, over to probability, option 4, and hit enter. And I get 120. Now that is the same as 5 times 4 times 3 times 2 times 1. Okay, so 5 factorial, that's exactly what that means. All right, so let me zoom back out a little bit. So you can do that. You can do that for all of them. Let's look at example number 4. Here's what this means. Now this one, if you just write it out, you'll see that you don't even really need a calculator to do this. But 4 times 3 times 2 times 1 over 2 times 1. And so anything divided by itself is just going to cancel out. And I'm left with 4 times 3, which is 12. Okay. But I am also going to go to Desmos right now and show you how to do this in Desmos. So let me open up my internet browser. Okay. So, and then move this picture. We are in Desmos. What I need to do is access this keypad down here. So if it is out of your way, you just need to click it up. Okay. We're going to click on this functions button. And I'm still in the way. And then you want to click on stats. Okay, that is your statistics. And I don't see the 5 factorial. Let me see if I just type the exclamation mark, if that'll work. 5 factorial is 120. Okay, so all I need to do here then is do shift and the number 1 to do factorial. So let's do 4 factorial, and all that's going to be divided by 2 factorial. And the answer that they give me here is 12, which is exactly what we got on our paper. So you can do this in the Desmos calculator and in your TI calculator. Let's go back to our notes. Alrighty. And then 0 factorial. I just added that on here so that you would know that that equals 1. Okay, just like anything to the 0 power equaled 1. Okay, next, let us talk about permutations. So if you want to add this little n and this little r out here with this p, and then we're going to talk about what this means, okay? So permutation would be like you're told to go to the store by your mom, and I need you to pick up some things for me. So you have a specific list of things to pick up. Okay? Now, in this case, the order will matter. The order will matter. So, here is our general formula. Here's our general formula. We're going to use that formula once, and then I'm going to show you how to do it in the calculator. Okay? So n represents the total number of objects that are available. R is the number of objects that you're going to use in your arrangement. Okay. So when you think of permutations, I want you to think of like your locker. the combination to the lock on your locker. 13, 7, and 45. If I typed those numbers, or not typed them, but if I, did it in a different order, my combination wouldn't open for me. So the order does matter. You have to do it in a certain way, okay? Alrighty. So somebody is taking American history, algebra, AP English, and chemistry. How many different ways can these 4 classes be arranged on a schedule? Okay, so it is a permutation. Okay. There are 4 different classes, and there's 4 different spots because there's just 4 periods in a day. So, all right. So notice that when both of these numbers, N and R, are the same, we have a little shortcut that we can use, which is just N factorial, whatever that number is. So this is the same as 4 factorial, which is 4 times 3 times 2, which is 24. And I just ignored the 1 because it doesn't change anything. All right. What about the word dinosaur? How many different ways can we arrange the letters in the word dinosaur? Again, there's 8 letters and there's 8 spots available. So this will be 8P8. All right. And that's going to give me a big number. 40,320. Now let me show you how you can do this in the calculator. So I'm going to start here with my TI first, okay? I am going to need to type in the first number, and then I need to go pick this option. So I'm going to go back to math where I found the factorial, go over to probability, and then you see the NPR right there is option 2. So I'm going to go down and just enter and select that. And now it's going to give me the option to type in the other number, and I hit enter. All right, and so that's the same value that I got here. Again, type the first number, click math, go to probability, select the P option for the permutation. Okay, let's see how we're going to do this in Desmos. Well, I'll use the next example to do it in Desmos. Okay. All right, now I have a little arrow here because I want you to kind of either flip your paper over if you print one-sided like I do, or grab a sheet of scratch paper. I want to add another example. I didn't realize that both of these used the shortcut when I created this. So I want to give you an example of a permutation where the letter or the numbers N and R are not the same. Okay. So there are 16 players on a baseball team. Okay, 16 players. How many ways can the coach make a 9-player batting order? 9-player batting order. So I have 16. He's going to pick 9. All right, he's got to pick 9. So 16P9. Now, if you want to use the formula, remember what the formula is. N factorial divided by N minus R factorial. So here's how that would look in the formula. 16 factorial over 16 minus 9 factorial. And then you could simplify that if you don't have a special kind of calculator to do that. You could just do 16 times 15 times 14 and get your huge number and then divide that by what you get in the denominator. But let's go look at the Desmos calculator. So I'm going to go back to Desmos. All right. So here, what I'm going to need to do is open this keypad, go to Functions, click on Statistics if it's not already there, and then select the NPR. And it's going to pop up a parenthesis. What I need to do is type in the N value first, comma, and then the R value. In this case, it's 9. Oof. And then it gives me this answer, okay, which is ginormous. He's got 16 players, and he's going to put 9 of them there. So this is a huge number. Remember, in this case, you would need to move your decimal place 9 places. So let me just write what this looks like. Let's see. 4, 1, 5, 1, 3, 4, 7, 2. I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now let me go back to my notes. And here is what this looks like. Okay. It's a big, big, big number. Big, big, big number. Okay. So that is permutations. Now what we're going to do is look at some permutations that repeat some things. So what do we do when there's repeats? Okay. How many different 10-letter arrangements are possible using the letters in the word automobile? And notice that the O is there twice. So it's going to change some things for me. Okay, so here's what I'm going to do. I'm going to count up how many, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 original spots. So that's 10 factorial, okay? And then there are one letter that repeats 2 times. So 2 of the spaces are the same. So I'm going to do 10 factorial divided by the repeated value. All right. And then again, I can type this into Desmos or into my TI calculator, and I'm going to get a big number. Okay. 814,000. There we go. So that is the number of different ways that we could possibly rearrange automobile. Let's look at the word disappear. And the reason I have a second example like this is because I want you to see what happens when 2 of the letters repeat, okay? So what we're going to do in this case is, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So there's 9 total spots. So 9 factorial. The A repeats twice, and the P repeats twice. So I just write it like this. So for each letter that repeats, now if it repeated 3 times, I would put 3 factorial. Okay, so just keep that in mind. I have 2 letters that have 2 appearances. Okay. All right, and so if I type this in, I'm going to get another big number, 90,720. All right, so that is permutations. It is starting to rain hard out there. All right, let's go on to our next page, and we're going to talk about combinations. Combinations are a little different because with a combination, so please do not confuse this with like the combination to your locker. Because the order does not matter here. That is the difference. So you're going to end up choosing whatever you want, whatever order you want. So I think of it as permutations are picking, combinations are choosing. When you pick something out, you're following a certain list. When you're choosing what you want, it's all up to you. Okay. Again, N is still the number of objects available. R is still the number of objects that we're going to use in the arrangement. So this is the official formula. And of course, this is a shortcut when the N values repeat. Okay. Alrighty, so let's look at example 10. There are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday party? So what we're going to be doing is 24 students total. He needs to choose 8 of them. So let's put this into the formula just so that you can see what it will look like. So the 24 factorial over r factorial times, subtract n minus r. Okay, so I'm going to do 24 minus 8 factorial. So let me extend this a little bit. All right, and so when I type this in, should this be a minus or a multiply? I'm going to need to double check that. I might have written my formula wrong. But let's go to Desmos and type this in and see what we're going to get. Desmos. Okay, so this time I'm still going to go to function, still going to go to stat, but instead of NPR, I'm going to choose NCR. And I've got 24, 8. And there's my answer. Okay. 7, I'm going to write it sideways. 7, 3, 5, 4, 7, 1. So you're not expected to evaluate these by hand or by working it out the long way. I do encourage you to use your technology to help you. Okay. Definitely encourage you to use your technology. All right. Let's give example 11 a try. Why don't you pause the video and see if you can do this one on your own? Hey guys, welcome back. I did go ahead and correct our equation here. It should be multiplication. I'm not sure why I put a minus sign. Okay, so just r factorial times n minus r factorial. All right. So for this problem, 85 total players on the team. How many ways can the coach choose 3 to represent the team for the coin toss? So 85, choose 3 players. So we're just going to type this into Desmos. Here we go. And I'm actually, since it's still up, let's see, 85,3. And there's my number, 98,770. Alrighty. So now let's talk about permutations and combinations, because these do get confusing. So I've already kind of done this for you. I wanted you to evaluate NPR for both N and R being 9, and then again for C. a permutation, and a combination. And when you get your solution from that, this is the permutation answer. This is the combination answer. So why is there such a big difference? The combination is a lower value because the order doesn't matter at all. So with combinations, the order doesn't matter. All right. So when you're considering which one to use, these are my little notes kind of for you in one place. Okay. And so here's what we're going to do. I am going to do these 4 problems and we're going to decide, is it a permutation or a combination? Okay. So how many ways can 4 candy bars be chosen from a store that sells 30? Honestly, I saw the word chosen, right? When you can choose, it's a combination. So 30 candy bars total, and you're going to get 4, okay? How many ways can 13 students line up for lunch? Well, the order is going to matter here, okay? So I'm going to have 13 students, and this will be a permutation, okay? How many ways can 12 swimmers finish in first, second, and third place? Again, the order of how they finish matters for the placement. So 12 players, 3 of them, okay, are going to end up coming in first, second, and third place. And then finally, how many ways can Miss Sullivan choose 2 students from 27 to help put away calculators? 27 total. She's going to choose 2. Okay. And you can evaluate these. Why don't you practice in the Desmos calculator or your TI calculator and evaluate these? Okay. If you need to pause the video while you do that, that's great. And then I will put the final answers up here for you in just a minute. All right, and so I have put the final solutions or number values up here. Again, just notice that whenever you have a permutation, there tends to be a lot more options because the order that things happen, they matter. The order matters with a permutation, okay? Combinations. Typically, you're going to see the word choose. That can help you for sure. All right. That's all that we have for today, guys. I will see you next time.